the Chapter 4 review packet. I'm going to go through it real quickly, so make sure you follow along carefully. I'm just going to go through and work out each problem very, very quickly. Try to make this video as short as possible. Number 1, state whether the variable is a discrete or continuous. The number of cups of coffee sold during lunch. Remember, discrete is something that you can count, continuous something that has to sort of be measured. So this one would be discrete, B. Number 2, same thing, discrete or continuous. The height of a player on a basketball team, well, height player could be 6'1", 6'1 1/4", 6'1 1/2", 6'1 7/8", so on and so on. So that's continuous, which is A. Number 3, random variable X represents the number of cars per household in a town of 1,000 households. Find the probability of randomly selecting a household that has less than 2 cars. Well, if we want less than 2 cars, then what we're going to do is add together the probability that has 0 cars plus the probability that has 1 car. Probability that has 0 cars is 125 out of 1,000. Probability that has 1 car is 428 out of 1,000. Add those together and we get 553 out of 1,000. Divide that, because our answer is given in decimal form. We divide it on our calculator and we end up with 0.553, which is letter C. Number 4, random variable X represents the number of cars per household in town, 1,000 households again. Find the probability of randomly selecting a household that has at least 1 car. So if it's at least 1, that means it could be 1, 2, 3, or 4. So all we really want to get rid of is the probability of 0. So I'm just going to take 1. That's a whole probability. Remember, all probabilities got to add up to 1, minus the probability of 0. Well, that's 1 minus probability that a household has 0 cars is 125 out of 1,000, which leaves us 875 out of 1,000. Divide that again and you get 0.875, which is letter B. Number 5, determine what's missing from the probability distribution. Remember, probability distribution always has to add up to 1. So all I'm going to do is take those numbers that they give us, 0.57, and add them all together, 0.07, 0.16, 0.02. Add all those together, subtract it from 1, and that should tell us what's missing. 0.57 plus 0.07 is 0.67, 0.67 plus 0.16 is 0.80, 0.80 plus 0.02 is 0.82. Subtract that from 1. That means we were missing 0.18. And that was letter D. Number 6. Number 6. You could just put it in the calculator, you could make the chart. I'm going to show you what should be in the chart, but I actually put mine in the calculator to do it, and I'll explain that here in a minute. If we're going to make the chart, you got your X, you got your P of X, you got your X times your P of X, so you take those first 2 and you multiply them. Then you got your and when you do all that, I'm not gonna actually do these, but when you multiply X times P of X, you add all those up, so you do the summation, and whatever that summation equals, that's what your mean is. That's the mu. Then your next column would be X minus mu. Then your next one is X minus mu squared. And then the last one that you need is X minus mu squared times P of X. So you take whatever's in this column times whatever's in this column, and that's what goes here. Then here you add all those up, and when you get that, they all add up. That's your variance. Now if you have a and once you find your variance, to find your standard deviation, remember that's your sigma. Variance is sigma squared. Standard deviation is just sigma. Once you to find your standard deviation, you just take the square root of whatever you got for your variance. That would give then you would have your mean, you'd have your variance, and you'd have your standard deviation. I just plug mine into the calculator. When you put them in the calculator, all you do is put in all the numbers in list 1, you put in all the x's, and in list 2, you put in all the p of x's, all the probability of each one. Then once you do all that, remember you go back through and you hit stat button again, and you want to calculate. And when you calculate, you punch in, you want number 1, which is the one variable. Sorry, I forgot my 1 there. You want the 1 variable one. And then once you have that pulled up, you got to hit second, then 1. That's going to put in list 1, comma, second, list 2, or I'm sorry, 2, which is list 2. Then all you do is hit enter, and it's going to pull up all the stuff for you, and it'll pull up. Remember, it's going to pull up X bar, and it's going to pull up sigma x, and that's your mean and your standard deviation. Well, for this one, the mean was 1.23, and your standard deviation was 0.32, and that's letter D. So you can do it either way, either using the chart, which is longer, or if you have the correct calculator, you can use that. Number 7, 1,000 tickets are sold at $2 each. One ticket will be randomly selected, and the winner will receive a color television valued at $350. What is the expected value? Person that buys that one ticket. On your expected value, remember expected value is the same as your mean, your mu. So when we go to do this, we're just going to do our x and then our probability of x. And this time there's only going to be 2 of them. Your x could be that you win, which if you win, then you win $348, taking off the $2 from the $350. Or your x could be that you lose, which means you lose $2. Well, the probability of winning is you get that one ticket out of 1,000. The probability of losing is all the rest of them, which is 999 out of 1,000. And what we do here is we take our x times our p of x, and we add all those up. Well, there's only 2 of them. So here, x times p of x is 348 over 1,000. Plus here, x times p of x is negative 1,998 over 1,000. We're going to add those up, and it's going to come up to be negative, I would just punch this into the calculator. If I was you, I'd just divide 348 by 1,000, and divide this and add those two together. But since I've already started working it out this way, 1998 negative 1998 and 348 give me a negative 1,650 out of 1,000. Divide that and we get negative 1.650 or 1.65. So we can expect to lose $1.65 for every ticket we buy, and that is letter A. Make sure you realize it's going to be a negative because most of the time you're going to lose, so it's a negative value. Number 8, find the mean of the binomial distribution. They tell us that n is 60, p is 0.2. Well, if it's a binomial distribution, your mean is just n times p. So all you do here is take 60 times 0.2, which gives you 12, which is letter C. Remember, for binomials, the mean, standard deviation, all that stuff, and the variance, all easier because you just have those 3 easy formulas. Number 9, same idea. They want us to find the standard deviation this time. Remember, standard deviation is sigma, and all it is n times p times q, and you take the square root of that. Remember, q stands for, q is just 1 minus whatever the probability was. Q is like the complement of it. So this time, 1 minus 0.89, which is 0.11. So we take the square root of n is 400 times p, which is 0.89 times 0.11. Do the square root of that, and our calculator gives us 6.26, which is letter B. Number 10. A test consists of 850 true or false questions. If a student guesses on each question what is the mean number of correct questions, this is a binomial distribution because you just have a correct answer and a wrong answer, so you have a success and a fail. So to find the mean, again, all we're going to do is take n times p. Well, n this time, that's how many total questions, is 850. And the probability of getting a true or false question right is 0.5 or 1/2. So we just multiply that and we get 425. And that is letter B. Number 11. Number 11 is another binomial distribution. So we can use all the rules for the binomial distribution. Again, they want us to find the mu and the standard deviation. So again, mu equals just n times p. N is your total number here, and the total number this time is 40. So n equals 40. P equals, let's see what they tell us, 0.17. We're going to need Q here in a minute so we can find it. You just take 1 times that 0.17, which is going to be 0.83. For the mean, it's 0.40, 40 times 0.17. Do that on your calculator and you get 6.8. For the standard deviation, for the sigma, it's the square root of 40 times 0.17 times the Q, which is 0.83. Do that on your calculator and you get 2.38. And we look at our answers there, and A has 6.8 and 2.38. So the answer is A. Number 12. It's another binomial distribution, same idea as the last one. This time N equals 420, P equals 0.16, and Q equals, we subtract that from 1 and you get 0.84. We do our mu, which is just N times P, and you come up with 67.2. Standard deviation, you do N times P times Q, and you take the square root of all that, and you end up with 7.51. And let's see here, that is D. Number 13. Assume a male and female births are equally likely, and the birth of one child does not affect the probability of the gender of any other child. Find the probability of at most 3 boys and 10 births. Again, this is a binomial distribution. So in a binomial distribution, to plug it into our calculator when we're looking for probability of at most or something like that, we need to know N, P, and X. Those are what we're going to plug into our calculator. This time N is 10, because we're taking out a 10 total births. P is 0.5, and our X this time, since we want the probability of at most, let me read it again to make sure. Probability of at most 3 boys, so that means we want the probability of 1 plus the probability of 2 plus the probability of 3. And I forgot one out in front here, probability of 0. Could be 0 boys also. Trying to keep that separate there. So we want probability of 0, probability of 1, probability of 2, probability of 3. We're going to add all those up, and what you're going to have to do is plug them into your calculator. When I did that, probability of getting 0 boys out of 10 births is 0.00098. Probability of getting just 1 boy out of 10 births is 0.0098. Probability of getting 2 boys out of 10 births is 0.0439. And the probability of getting 3 boys out of 10 births is 0.1172. We add all those up, and let's see, when I add them all up, I came up with 0.172, which is letter D. Number 14. Probability that an individual is left-handed. This is another binomial one, and I'm going to use a calculator on this. Remember, on your calculator, what you're going to have to hit second. For your binomials, you're going to hit second, vars. And then this time, since it's a binomial, we want 0. 0 is the binomial one, the binomial distributions. They tell us that our N this time is 23. That's how many students are in the classroom. Our P, our probability, is 0.19. And we want to pick 5 left-handers. So that means our X is 5. When you punch it into the calculator, again, you're going to hit second, bar 0. It's going to pop up the thing that looks like binomial and have the parenthesis, and you're just going to put in N, comma, P, it's supposed to be a P, my pen's not writing, comma, then X. So you punch all that into your calculator, you close your parenthesis, and when I did that on my calculator, it came up to be 0.188 something. And I'm not sure why that's answer B and that's the answer it should be, but they also put 0.19 on here as one of their answers. So I would accept B or C on that one. I'm not sure why they put both those answers on there, too close together. Number 15, the other binomial probability. This time our N is 12. We're picking out of 12 men. Our probability is 65%. And we want to select exactly 4 men. So we're going to do the same thing that we did on this one up here. Punch it in the calculator using the second bar 0, and then you punch in NP, and X. When I did that, I ended up with 0.020, which is letter C. Number 16 is a geometric distribution. Remember, to be a geometric distribution, it's you're figuring out how many of something it's going to take till there's a success. So this time it says Chauncey Billups of the Detroit Pistons makes free throws at 88% of the time. Find the probability that he misses his first shot and makes the second shot. So we want that his first make is going to be on his second shot. So that's just going to be a probability at 2, but we're using the geometric distribution setup. When we do that, remember that that's the D on your calculator. So you hit second, and again you hit bars. Then you go to D, and it's going to say Geo Met something PDF or something like that, parenthesis, and in the parenthesis we're going to stick in the probability, then the X, close the parenthesis. This time we stick in, so when you punch it in, you're going to punch in 0.88 and 2. And when you do that, it comes up to 0.1056, and that's letter C. Number 17. I'm not sure about, so I'm going to skip over that one. I'm not sure about it because of the way it's worded. Number 18. Use Poisson's distribution. Remember that that's instead of, just like with the geometric, instead of D on the calculator, it's the B on the calculator. Statistics professor finds that when he schedules an office hour at 10:30, an average of 3 students arrive. So that means our mu this time is 3. Remember, whenever you're using Poisson's distribution, it's you need that mu. That's your main thing that you need. Use Poisson's distribution to find the probability that in a randomly selected office hour no students will arrive. So this time we want our X to be 0. So we want the probability of 0. Remember, this is one you just about have to stick it in the calculator. So on the calculator, you hit second, hit bars, go to B, hit enter. Once you hit enter, it pops up on the screen, and then you got to put in your mu So you put in mu, then you put in a comma, then you put in your x that you're picking this time, which this time is 0, then you close the parenthesis, hit enter again after that, and when you do all that this time, it tells you that it comes up to be 0.0498, which is letter A. Number 19. Given the probability that federal government, that federal income tax return is filed out incorrectly with an error in favor of the taxpayer is 20%, what is the probability that of 10 tax returns randomly selected for an audit, 3 returns will come or will contain only errors favoring the taxpayer? You got to remember the difference between binomial, Poissons, and geometric. Remember, binomial, they're usually giving us a percentage, and we're trying to figure out, and it's got to be, there's only successes and failures. With Poissons, we're trying to figure out what happens in a certain interval, and then I'm sorry, I said binomial. That first one I meant geometric. Geometric, we're trying to figure out how many come out in a certain event, or when our first success is. Binomial is we just have a certain number of trials that we're going through. So binomial, certain number of trials. Poisson is we have an average, a mu, and we're trying to figure out in a certain interval how many things are going to happen. And then geometric is when we have a success and failure, and that's all we have, and we're given a certain amount of trials that we're going to go through, and we want to know how many come out of that. In this case, since you could have 1, 2, 4, 5, 6, 7, 8, 9, 10 instead of just the 3 returns, that means it's a binomial, which is A. Number 20 says the same thing. What is the probability that when 10 tax returns are randomly selected for an audit, the 6th return, so this time we're looking at that first success, that 6th return, and that's going to be a geometrical, which is B. And 21, probability that a federal income tax, same thing. What is the probability that of the 10 tax returns randomly selected for an audit in a given week? So now they give us an interval. Well, as soon as you see that interval, what that tells you is Poissons, which is letter B. A student has 5 motor vehicle accidents in 1 year and claims that having 5 accidents is not unusual. Use the frequency distribution below to determine if the student is correct or not. So this student had 5 accidents. If we look at that, what first thing we need to do is we need to add up all of the students there. So 260 plus 500 plus 425 plus 305 plus 175 plus 45. And that gives us a total of 1,710. So that's our bottom number of our probability. And this student had 5, so we look out there at 5, and there was 45 students out of the 1,710 that had 5 accidents in a year. We divide that and we come up with 0.026. They want to know whether the student's correct. This is about 3%. And remember, anything that's less than 0.05 or 5% is unusual. So no, this student is not correct. It is very unusual for somebody to have 5 accidents in 1 year. 23, an insurance actuary asked a sample of senior citizens that caused the cause of their automobile accidents over a 2-year period. The random variable X represents the number of accidents caused by their failure to yield the right-of-way. Use the frequency distribution to construct a probability distribution. So we want to construct a probability distribution. I'm going to draw it sideways this time. Usually I draw it up and down. But we're going to have X, which is just going to be the number of accidents. And then we're going to have our P of X, which is our probability each time. We got 0, 1, 2, 3, 4, 5. And all you do here, first thing you got to do is looking at your frequency distribution. You got to total up all the senior citizens. So it's 4 plus 3 plus 12 plus 3 plus 2 plus 1. And that gives you a total of 25. And what you're going to do on your probabilities here is just put each one of these. So this is 4 out of 25. This is 3 out of 25. 12 out of 25. And we're going to change each one of these to a decimal here in a minute to put into our probability distribution. 3 out of 25. 2 out of 25. And 1 out of 25. And we're just going to change each one of those into a decimal. This one's 0.16. This one's 0.12. This one is 0.48. This one is 0.12. This one is 0.08. And this one is 0.04. So that's your probability distribution. In a pizza takeout restaurant, the following probability distribution was obtained. The random variable X represents the number of toppings for a large pizza. Graph the probability distribution. Whenever we graph these, remember we're going to make a histogram. Probably didn't leave myself room for a histogram here, but we're going to do it. So we got P of X on this side. And we'll make this 0.10, 0.20. You split it up depending on the graph, or depending on what the information is, how you need to split it up. On the bottom is going to be our toppings. And there was 0, 1, 2, 3, and 4. For 0, it was 30%. So we go up to 30, make our bar. For 1, it was 40. For 2, it was 20. For 3, it was 6%. So that's going to be down in here somewhere. And for 4, it was 4%. So that's what our histogram should look like. If you were asked to do it, which they didn't ask this time, but you could say that that is skewed right because it tails off down this way to the right. Number 25, determine whether the distribution represents a probability distribution. If no, identify any requirements that are not satisfied. On 25, first thing I look at in there, and I can tell that it's no, it's not a probability distribution. And the reason is the probability at 3 is a negative. And all probabilities are between 0 and 1 inclusively, or inclusive. So in other words, it can be 0, it can be 1, and it can be anything in between there, but it can't be anything more or anything less. Number 26. Find the probability distribution, from the probability distribution, find the mean standard deviation of the random variable, which represents number of cars per household in the town of 1,000 households. On this one, again, the easiest way and what I'm going to show you to do here is just put it in the calculator. We could make the big chart and find it, like I showed you on one of the previous ones, but I'm not going to go through and draw that chart this time. I just punched this into my calculator. When you punch it into your calculator, you put all your X's in to the list 1 on your calculator. Remember, that's under stat. You go to stat and edit, and you can punch in all the X's in list 1, so that'd be 0, 1, 2, 3, and 4. You put all your P of X's into list 2. Once you have both those lists in your calculator, then you hit stat, calculate, and then you just hit the number 1, which is 1 variables. Then you hit second, that'll take you back to your regular screen. You hit second, and you hit the number 1, which that pulls up L1. Then you hit a comma, then you hit second again, then you hit the number 2, which that pulls up L2. Once you have L1 and L2 both up there, all you gotta do is hit enter, and it's gonna figure everything out for you. Once you hit enter, they want the mean and the standard deviation. Remember, on the calculator, X bar is the same as the mean, or the same as the mu. So they want you to look at that, and then the standard deviation, that's sigma X. That's your standard deviation. So once I did that, I came up with mu was equal to 1.596, and sigma of X, or sigma, the standard deviation, was 1.098. Problem 27. Decide whether the experiment is a binomial experiment. If it is not, explain why. You observe the gender of the next 300 babies born in a local hospital. The random variable represents the number of girls. Remember, on binomial experiments, we can only have successes and failures, and you got a list there that you can go down through. Remember, there's 3 or 4 things that make something a binomial, something a geometrical, something a Poisson distribution. So look at those, make sure you know those. This one, since we want chances that you get a girl, then it's either a success or a failure. So yes, it is binomial. (28) Decide whether the experiment's binomial. You test 4 pain relievers. The random variable represents the pain reliever that is most effective. So this one is no, because you could pick A is the most effective, or B is the second pain reliever is the most effective, or whatever. So there's 4 possible outcomes. And a binomial distribution can only have 2. 29. 26% of people in the United States with internet access go online to get news. A random sample of 5 Americans with internet access is selected and asked if they get news online, identify the values of N, P, Q, and list all the possible X's, all the possible outcomes. Alright, so N is the total number that we're picking. And we randomly picked 5 Americans, it said. So that's our N. The probability is the 26%. We change that to a decimal, so it's 0.26. And then Q is just 1 minus that 0.26, which is 0.74. All the possible outcomes. Well, when we do all of this, we pick our 5 people, we could have 0 that say that they go online to get their news. We could have 1 that says that they do. We could have 2 that says that they do. We could have 3 that says, 4, 5, all those. So those are our possible X's. Number 30. Number 30 is a geometric distribution. So we're going to use the stuff that deals with geometric distribution. The way I knew it was a geometric distribution, because it says we have 100 items, so we have a set amount. Assume that the probability of defective computer component is 2%. Probability of the first defective is found in the 7th component tested. So on this one, since it's geometric, things we need to know N, we need to know P, we need to know Q, and we need to know our X. This time N is 100, that's how many components we have. Our probability is 0.2. We subtract that from 1, and we get 0.8, that's our Q. So this is probability that's defective, this is probability that's not defective. And then the X we're looking at, we want to pick the 7th one. We want to look at the 7th one and see if it's defective. Again, what we do on the, I'm going to punch this into the calculator. On the calculator, you hit second, vars, then you, actually we're not going to do that. You go down to D, hit enter, and that's going to pull up. After that, it's going to look something like this. It's going to say Geomet, PDF, and then have the parenthesis, and then you got to punch in your no, I'm sorry, don't punch in your N. You punch in your P and your X. Once you do all that, it gives you an answer. You could also use the formula. Remember the formula for probability 7? It's not really that hard. Poisson's is the one that's hard. It's P times Q X minus 1. So if we punched all that in, P this time is 0.2 times Q, which is 0.8. X minus 1, well this time we went to 7th, so it's 7 minus 1. So that'd be 0.2 times 0.8 to the 6th power. You punch all that into your calculator, and whichever way you do it, whether you're using the formula or using the calculator, you still come up with 0.0524. Number 31. 31 uses Poisson's distribution, and I knew that because it says the towing company averages 2 calls per hour, and we're trying to find a certain, so it's, we know that mu is 2, and we're trying to find for a certain interval, which is an hour. So anytime it's dealing with some kind of interval like that, it's Poisson's. Determine the probability that a randomly selected hour, the number of calls is 6. So we're actually trying to find the probability 6. And again, you could try that big long formula if you want out longhand. I'm not going to. I plug mine into the computer or into the calculator. You hit second, vars, hit B, go to B. That's Poissons. And you hit enter. Once you hit enter, then you hit your mu, which in this case is 2. Then you hit a comma. Then you hit your x, which in this case is 6. Then you close your parenthesis. You hit enter again. And it pops up your answer. And your answer this time should have been 0.012. So about a 1% chance that in a certain hour we're going to get 6 calls. 32, use Poissons again. This time our mu is 0.55. And our x this time, they want us to do, it says use Poisson's distribution. The fire station will receive fewer than 2 calls. Well, fewer than 2 calls could be 0 or 1. So we actually have to find the probability of 0 and then add it to the probability of 1. Add those two together and that's going to give us our total answer. I put it in the calculator, doing all this stuff up here again. But you have to put them in separately, so you'd have to put in 0 here, and then come up with that answer. Then next time put in 1 in there for x, and when I did all that, I came up with 0.577 for 0. That means about 58% of the time in a day they're going to get 0 calls, and then 1 call, about 32%, 0.317. Then I'm just going to add those two together, and I got 0.894. So about 89% of the time that fire station is going to get 0 or 1 call in a day. Right, use this. You can skip through it and try to find the ones that you don't know, skip over the ones that you do know. Test next class.